Alright guys, so here's a couple example problems we want to take a look at just to hopefully kind of solidify these relationships that we talked about. So the first one that we're going to look at is the chord situation. Basically you just have the intersection of two chords, and we're going to look at segment lengths, or trying to find relationships between segment lengths that result from this intersection. So we're going to create this scenario where we have two triangles. And those two triangles, we went through the proof, found that they were similar, so we can basically match up their corresponding parts. So the first ratio that we want to write is this ratio of this side here, and we match it up with its corresponding part. UB, we're going to match up with BT. So the ratio of UB to BT, that's going to, that should be the same ratio as if we go over and match up WB and VB. Okay, so that ratio should be exactly the same. So we just plug in what we know here. So UB we know is x minus 4. So we've got x minus 4 over BT, which is 5. That's going to be equal to WB, which is 2 plus x, over, and then VB is 8. So there's our proportion, just using that chord-chord relationship. Again, if you don't need to draw the triangles, then don't draw the triangles. It just kind of helps me to visualize what's going on. So to go through and solve, this is a proportion, so we cross multiply. Make sure you use parentheses, guys, because this needs to be distributed. So 8 times x minus 4 is going to be equal to 5 times 2 plus x. Distribute, and we get 8x minus 32 is equal to 10 plus 5x. Combine your like terms, so we're going to move the 5x over here, combine that with the 8x. We end up with 3x. We're going to add 32 to both sides, so that's equal to 42, and x is equal to 14. Now what we ultimately want to do, we figured out what x was, but we want to plug that back in and figure out what the segment length is, UW. So UW is going to be equal to x minus 4 plus 2 plus x. So plug in our x value, we get 14 minus 4 plus 2 plus 14. And so UW is equal to, what is that, 26. Alright, so that's the chord-chord relationship. The next one is the secant-secant intersection. So this is the scenario that we're going to take a look at. And if you remember, the general rule was basically part times whole. So there's the part. We've got AB, and we're going to match that up with AE. And the ratio is going to be AB. So here's one triangle here. And then the other triangle, I'll just put in a different color here. It's going to be this green triangle right here. So just taking a look at these two different scenarios, we've got part times whole, part times whole. So AB compared to AE is actually should be in green, because that's the part from the green triangle. And we're going to compare that to let me see, AD, because we need the red, compared to AC. So when we multiply this out, we end up with AB times AC. There's your first cross multiplication, and that is again part times whole. And then the other one is AE is the part, AD is the whole, so it's equal to part times whole. So we'll show you a quick application of this. Here's the problem. The problem here is we want to find AC, and so again we're just going to apply that property. So we've got part times whole, so that's CD times CM. That's going to be equal to CB times CA. So plug in what we know. CD is 10, CM is the whole thing, So it's not just the 17, it's 10 plus 17, so I'll write that out. You don't necessarily have to write that out if you recognize it. CB is 3x minus 3. And again, make sure that you use parentheses. It's going to be that quantity times the total quantity. So 3x minus 3 plus 21. Okay, go through and simplify here. We've got 27 times 10 is 270. That's equal to, this is going to simplify to 3x minus 3, 3x plus 18. And then we need to FOIL this, so we'll end up with 9x squared. Outside is 54 minus 9 is going to be 45, so plus 45x minus 54. That's equal to 270. So here we've got a quadratic. We need to make sure that we get everything on one side. So 0 is equal to 9x squared plus 45x. And then 270 minus 54 is going to give you 216, so minus 216. We can actually factor out a greatest common factor from this thing. So that greatest common factor is going to be 9. And that leaves us with x squared plus 5x. And then 216 divided by 9 is going to be, let me see, 24, looks like. All right, so that quantity is equal to 0. Factor this in here, and you'll get 9 times x plus 8, x minus 3. So we know zero product property tells us that x is going to be equal to negative 8, or x equals 3. Plug in a negative 8, and you would get a negative value for the length of that particular side. So this one is no solution. That one doesn't work. X equals 3 is your only solution. And AC ends up being 3 times 3 minus 3 plus 21. AC ends up being 27. So again, this is the important part, making sure that you can apply this, that segment intersection, and the relationship that it's part times whole equals part times whole. All right, last one. We've got a tangent and a secant. So the relationship here is, it's really kind of like part times whole again, but here on this tangent, you've only got the part and the whole are the same thing. So the relationship that exists is AB squared is equal to the part times the whole. So the part would be BC times CD. So we just need to plug in what we know. Here we've got 15 squared is equal to BC is 9. And then the whole thing is 9 plus 2x plus 4. So we end up with a 2x plus 13. 15 squared is 225. That's equal to 18x plus, I believe it's 117. All right, so just to finish this up real quick, we need to solve for x. So subtract 117 from each side, and we end up with 108 equals 18x. Divide by both sides on, divide by 18 on both sides, and you get x equals 6. And ultimately, they want to know what CD is. So CD equals 2 times 6 plus 4. CD equals 16. All right, so again, here's the important part, making sure that you understand the property. Anytime you have a tangent and a secant intersecting, we want to make sure that we do the tangent, the length of the tangent segment squared is equal to the part times the whole.